Hello friends and welcome at my channel. Today let's discuss one more function which is going to be not a polynomial function as in the previous results. So this function looks like f of x equals to x squared minus 2x plus 2. So far so good, but now we're dividing it by x minus 1. Well, what does it mean? That means that we are not allowing to have x being equal to 1. This is the very first point. So the domain is everything but 1. And we just move on with symmetry, where we can immediately see if we rewrite it as x squared minus 2x plus 1 plus 1 more divided over x minus 1. This is going to be x squared. I can roll it together as x minus 1 squared divided over x minus 1 plus 1 divided over x minus 1. This is x minus 1 plus 1 divided over x minus 1. And now you can immediately see x minus 1 by itself would be a simple function, but because of the division by x minus 1 in the denominator here, we're having some troubles. And we are going to have no symmetry here because x minus 1 is a straight line, and 1 divided by x minus 1 is a function which is having troubles at 1. So basically 1 here and minus 1 there. And in the long run, we're going to look like this. And at 1, we are going to have, well, you see, this is a kind of shifted function. So if we shift it by 1, that's maybe an interesting point here. So it looks like it looks like x plus 1 divided by x, right? So we just shift both cases by 1 to the right. Well, there is a kind of hidden symmetry, but not considering the origin, non symmetry considering the y-axis. Okay, so no simple symmetry. Can I prove it really, like correctly? Sure. F of minus x is just minus x squared minus 2 times minus x plus 2 divided over minus x minus 1. It's x squared plus 2x plus 2 divided over minus x minus 1, not equal to f of x. And what about minus f of x? Well, just change the signs in the numerator, for example. Minus x squared plus 2x minus 2 divided over x minus 1. And those two are not equal either. So no symmetry as we previously decided. 3, limit x towards infinity. Obviously, we are going to behave like x minus 1, which goes to plus infinity, and x running toward minus infinity. We're going still to behave as x minus 1. So this is minus infinity. So far, so good. But in this case, because of 1, where we're dividing by 0, we have to be careful what's happening if we're approaching 1. So slightly bigger than 1 means this one is going to be 0, and this one, the denominator is a very small positive number dividing 1 by a small positive number, giving us a huge positive number. And if we're considering this case, this is the same story, but now we are slightly less than 1, so 0.9 or 0.95. We're dividing 1 by a very small negative number. The result is huge, but negative. All right, number 4, 0 points. X squared minus 2x plus 2 divided over x minus 1 equals to 0. We have a fraction where the numerator is equal to 0. The denominator is surely unequal to 0. So we want to put only the numerator, knowing that x is not allowed to be 1, equals to 0. We're using the so-called PQ formula, one of the formulas that is allowed for you to solve the equation. You can use it, and we see immediately this expression is less than 0, so no 0 points. All right. Number 5, we have to write the derivative. Maybe let's write again our function. So what is the derivative? Well, x minus 1 gives you 1. And this one is giving you minus 1 divided over x minus 1 squared. So this is x minus 1 squared minus 1 divided over x minus 1 squared equals to 0. The denominator is unequal to 0. X squared minus 2x plus 1 minus 1 equals to 0. So we are having x minus 2 equals to 0. x1 is 0. x2 is 2. All right. F second prime of x. Well, this is just minus 2 coming up. This is 2 divided over x minus 1 cubed. F second prime at 0 is just 2 divided by minus 1 cubed, which is minus 2, which is less than 0, so it's a max at 0. And let's see, this is minus 1 and this is minus 1, so 0 minus 2, it's a max. And f second prime at 2, this is 2 divided by 1, this is 2, so it's greater than 0, it's min, and the coordinates of the min are 2, and let's see, this is 1 and this is 1, 2, 2. All right. Do we have a point of inflection? No, we don't, because as you can see, the second derivative is never 0 because the denominator isn't allowed to be 0 and the numerator is just 2. So can we crash the graph already? Yes, we can. Let's do it. So no 0 points. We had troubles at 1. Let's see what's happening there. We know that on the long run, we're going to be approaching this line x minus 1, and we are having a min and a max. A max at, I think it was 0 and minus 2, if I'm right, and at 2, 2, the min. And don't forget that we are exploding just before 1 on the left-hand side towards minus infinity, and just after 1 on the right-hand side towards plus infinity. So it's look like this. Let's see, 2, 2, and 0 minus 2. It goes like this. Bad. Like this. Okay. So these, oh no, I have to pay attention here. Okay, slightly better. So this is the graph. All right. Thanks for watching and see you guys in the next video.